Hello, everyone, and welcome back to another episode of Solidity Fridays. Today, I'm joined with special guest David Kathoh. How are you doing, David?
I'm all right, Tamara. How are you doing?
Yeah, very well, thanks. Excited for this one. So today we'll be looking at on-chain governance and a nice repo that gives a nice template for doing on-chain governance. It's called the Federal Government as Solidity, and it's by Alex Kruger. He uses a lot of Open Zeppelin governance libraries, which is always a good way to go, I think, if you're doing something quite technical and there are libraries available by someone like Open Zeppelin. They have a nice introduction to what on-chain governance is like, so I thought we could start there. So this is mainly looking at Open Zeppelin's governor contract, which is their main governance Solidity contract. And so decentralized protocols are in constant evolution from the moment they are publicly released. Often the initial team retains control of this evolution in the first stages, but eventually delegates it to a community of stakeholders. The process by which this community makes decisions is called on-chain governance, and it has become a central component of decentralized protocols, fueling varied decisions such as parameter tweaking, smart contract upgrades, integrations with other protocols, treasury management, grants, etc. This governance protocol is generally implemented in a special purpose contract called Governor. The Governor Alpha and Governor Bravo contracts, designed by Compound, have been very successful and popular so far, with the downside that projects with different requirements have had to fork the code to customize it for their needs, which can pose a very high risk of introducing security issues. For Open Zeppelin contracts, we set out to build a modular system of governor contracts so that forking is not needed and different requirements can be accommodated by writing small modules using Solidity inheritance. You'll find the most common requirements out of the box in Open Zeppelin contracts, but writing additional ones is simple, and we will be adding new features as requested by the community in future releases. And it requires minimal use of storage and results in more gas-efficient operation. So it's really good that I think he used this governor contract. It's based on Compound's Governor Alpha and Governor Bravo. So there's two variants generally of the governor contracts. And then to be able to have a vote, there's something called ERC20 votes. So it's an extension of ERC20, and it keeps track of votes, and vote delegation is one case where you can use ERC20 votes. The shorter one is more generic because it can support token supplies greater than 2 to the 96, while comp variant is limited in that regard, but exactly fits in the inherent interface of the comp token that is used by Governor Alpha and Bravo. Both contract variants share the same events, so they are fully compatible when looking at events only. I think in the project we're looking at today, he doesn't use the comp version. He uses the bigger one, with the
Yes, 20 votes, yeah.
Yes, he does. Okay. And I think that makes sense because he's trying to say if you were to put the entire government on chain, you could do that in this way. So you want to have more than 2 to the 96 possible votes. Otherwise, not all citizens could vote, and they would kind of defeat the purpose. Okay, then there's the governor and the governor compatibility Bravo. This is just saying that they share the same events, the two variants, but that they have different functions. Then there's something called a Timelock, and this is just for voting. I think there's a Timelock on the vote. Okay, then tally, that's to tally the votes, and then this is how to set it up. But we don't need to look at this, I think, for now in this tutorial, because we're going to look at a really nice example.
Yeah.
Cool. Should we dig into the example then?
Yeah, sure, can dig in.
Awesome. I struggle to read GitHub without dark mode. Cool. So it says deploying the United States government. This repo walks through deploying Open Zeppelin governance contracts and utilizing them to create and execute an on-chain proposal. It's a hard hat project because it was a few months ago that this was done. So I don't think Foundry was very in use back then. Yeah, and then to run the proposal scenario in your local hard hat environment, npx hard hat run scripts proposal scenario, and then you can deploy them and verify them on Etherscan. Cool. So the README doesn't give too much information on governance, but we just read some governance. It's the Apache 2.0 license. Cool. I think we'll look at the scripts later. Let's start with the contracts. David, do you think we should start with the government, or should we start small with the token?
No, we can start by the federal government to see how the project looks like. Yeah.
I just want to see if I can zoom in. That might help.
Yeah, that's better. Yeah.
Cool. So the first thing it imports 5 governance contracts from OpenZeppelin: governor compatibility Bravo, governor votes quorum fraction, and governor Timelock control. Should we maybe look at governor by OpenZeppelin before we look at this, because it's inherited it. So I have it open here. I don't have the other ones open yet. Cool, so this imports a bunch of utils and an interface. It's interesting, they have an ECDSA, which is the cryptography,
for signature.
Yeah, for signatures. So let's see how that gets used. Okay, this contract is abstract and requires several functions to be implemented in various modules. A counting module must implement quorum reach, vote succeeded, and count vote. A voting module must implement get votes. And additionally, the voting period must also be implemented. So, it's context, it's inheriting context, ERC 165. I think that's the supports interface ERC. EIP 712, iGovernor, IER 721 receiver. So it's going to be able to receive NFTs. And also 1155 NFTs. Using double-ended queue for double-ended queue bytes 32 DQ. Interesting. I haven't seen that before. I'm excited to see where it's used.
Yeah. Can you maybe explain about that? How?
So I'm not too sure. I'll have to see its implementation. But okay. I think, so we'll have like a queue, and then we'll go through it from the left and the right at the same time, as opposed to just traversing left to right or right to left. That's my understanding, but it's an assumption. So let's see actually how it gets used. Then safe cast for UN256 and timers for timers.block number. It's another one I haven't seen actually, I think. Cool. Ballot type hash. So they take the Ketchak and hash ballot UN256 proposal ID, UN8 support. But this could be any Ketchak. This is just what they decided. So the string is what they call ballot on. And they have an extended ballot type hash, which is again a Ketchak hashing the string extended ballot UN256 proposal ID, UN8, support, string reason, and bytes parameters. They have a struct proposal call, timers.block number, vote start, and then vote end, bool executed and bool cancelled. String private name, mapping, proposal. So we have multiple proposal cores, and then each of them is identified by a uint. And it's got this underscore because it's private. I mean, obviously nothing's truly private on chain, but it just means you won't see it when you look at this contract on Etherscan, or it's a bit obfuscated, so you don't see it always. Oh, here's our queue. Okay, so let's see what they say. This queue keeps track of the governor operating on itself. Calls to functions protected by the only governance modifier needs to be whitelisted in this queue. Whitelisting is set in before execute. consumed by the only governance modifier and eventually reset in after execute. This ensures that the execution of only governance protected calls can only be achieved through successful proposals. Okay. So it helps the modifier of only governance, and it only allows that governance can only happen through successful proposals. So I think it's an extra security measure.
Yeah.
So I was pretty wrong about the double-sided queue.
Yeah.
Okay, here's that modifier they were talking about. So it's called only governance. It restricts the functions that can only be executed through governance proposals. For example, governance parameter settings in governor settings are protected using this modifier. Okay, so this is probably things that these are things that we can't really vote on generally. It's only through the governance can it be altered. So it's kind of like only owner, but it's only governance, and the governance executing address may be different from the governor's own address. For example, it could be a time lock. This could be customizable by modules by overriding executor. The executor is only able to invoke these functions during the execution of the governor's execute function and do not under any other circumstances. And not under, sorry. That's, for example, additional time lock proposals are not able to change governance parameters without going through the governance protocol. Okay, that's really cool. So we could have
maybe
yeah,
we can look how that executor functions is implemented. Yeah, see how. See, it's coming from.
Here it is. Okay, so it's the address through which the governor executes action. It will be overloaded by a module that executes actions through another contract, such as Timelock. So I think in this federal government inheriting, this becomes the new governor executor. And it's an internal view virtual returns address, and it returns the address of the
contract.
The contract, yeah. Nice. Okay. And it's used a lot. Cool.
Yeah.
Okay, so require message sender. Interesting, message sender, they're using that OpenZeppelin function, not message.sender. But you'll probably find that message sender returns message.sender. Maybe we should check that out.
Yeah, should be the same as the contract address.
Yeah. Message sender, I think, is defined in context, so we probably won't even see it here. My bad. Let's go back to the top here. Ooh, cool. If executor is not equal to address this, then we have a bytes32 message data hash is the ketchak of message data. And then we loop until popping the expected operation, throw if DQ is empty. Okay, so while governance call.pop front, okay, yeah, so it's a queue. So we're taking off the first element. And if the first element is not equal to the message data hash, which is this ketchak of the message data, we continue until we get the element that is equal to the hash of the message data. And then we can continue. Cool. Okay, cool. Constructor, it's an EIP 721 with name and version. Version is actually a function, so they probably set the version in version first. Well, I don't know. Maybe we check out version. I'm not too sure how that would work. I've never seen a constructor passing in a parameter, a function.
Yeah, same here.
Oh, it always returns 1.
Yeah, the version.
Cool. Receive a function to receive ETH that will be handled by the governor, disabled if executed as a third-party contract. Require executor equals to address this. Okay, cool. And it's obviously payable because we're going to receive that ETH. So this supports interface, which will be the IERC 165. Public view, virtual override, both the interface and ERC 165, and it returns a bool. So in addition to the current interface ID, also support previous versions of the interface ID that did not include the cast vote with reasons and params function as standard. Okay, so this is just to make it compatible with other versions of this contract. And then, sorry, my cat's sitting in front of my screen now. I'm trying to move him. Okay, return interface ID equals, okay, so it's going to return a bool with this double equal sign. So checks, is the type iGovernor.interface ID
to the power, what is this?
Yeah, I think that's actually some kind of OR. And then so it's not actually a to the power sign because that's usually the two stars. I haven't seen this before, so I'm just checking. Oh, it has to do with typecasting. Maybe it's saying like, if this type is less than, or this type, which is, or maybe the same. So maybe if this type is the same as this dot card, also is this and then this, if that's true, or if interface ID equals type iGovernor.interface ID, or if the interface ID equals IERC 1155 receiver, or if you call to the super supports interface ID. If any of those return true, otherwise return false.
So that's just casting the interface ID.
Yes, that's just checking the interface ID. Cool, function name returns the name from the constructor. And then, sorry, just moving my cat again. What's after name? Or do I need to scroll down? Yeah, I do. Okay, cool. Version, we've seen that it just returns 1.
Yeah.
Then there's hash proposal. The proposal ID is produced by hashing the ABI encode targets array and the values array and the call datas array. And the description hash, which is bytes 32, which itself is the Ketchak hash of the description string. Okay, we saw something similar where we had the proposal being hashed, and now we have the description being hashed in a Ketchak 256 hashing algorithm. This proposal ID can be produced from the proposal data, which is part of the proposal created events. It can, oh my cat, sorry. It can even be computed in advance before the proposal is submitted. That's cool. Note that the chain ID and the governor address are not part of the proposal ID computation. Consequently, the same proposal with the same operation and same description will have the same ID if submitted on multiple governors across multiple networks. Wow.
Yeah, it should be the same hash.
Yeah, that makes sense, but that's really cool that it can be on multiple networks and be the same. This also means that in order to execute the same operation twice on the same governor, the proposer will have to change the description in order to avoid proposal ID conflicts. Yeah. Cool, so we hash this proposal. So we take in an address array of targets stored in memory, values, UN256 array, memory, bytes array of call datas, and then that bytes 32, which is that description hash, which was the ketchak of the description. It returns a uint256. It's also pure, virtual, and override. Where is it overriding from? Oh, maybe from that ECDSA. No, wait. What did we inherit from? I don't want to scroll all the way to the top. We inherited from it might be from the EIP 712. And then we return a uint256. So we first ABI encode the targets, the values, the call datas, and the description hash. Then we hash that through ketchak 256, and then we typecast that to a uint256, and we return that as an ID of this hash
proposal. Yeah.
Mm-hmm. Cool. Function state. This is overriding, and it's probably overriding from the we inherited from context. So it's probably a context thing. But let's see. So we take in that proposal ID, which is probably from the hash proposal, and we return a proposal state. So we have a proposal core, which was that struct we saw, stored in storage. Interesting. Yeah. Proposal. And yeah, so it equals, we have that mapping proposals, and you put in that proposal ID. So you get that specific proposal. If proposal.executed, return proposal state.executed, or if cancelled, return proposal state.cancelled. uint256 snapshot equals proposal snapshot proposal ID. We'll look at proposal snapshot soon, I'm sure. Unless you want to look at it now.
Yeah, we can look at it.
So it's also a public view virtual override. And okay, so what it does is it looks at, it finds the specific proposal from that mapping. It takes the vote start and it gets the deadline. And then maybe we look at get deadline. Why it won't be here? It'll be in the bottom probably. Oh, because it's an inherited thing. Oh, it's because we're using that time. We were using the
Timelock.
Timelock, yeah. So that's where we're getting the deadline. Yeah. Nice, yeah.
Yeah, Timelock.
Okay. Sure, there's a lot here. Okay, here we are getting state. So if the snapshot equals 0, then it reverts governor unknown proposal ID. If snapshot is greater than or equal to block number, then we haven't reached our deadline. So we return proposal state.pending.
Yeah, still pending.
Deadline equals proposal deadline proposal ID. This proposal deadline, I saw it down there. We can look at it later. It's it just calls get deadline, I think, at the end of the day. And if deadline,
yeah, it's called get deadline.
Yeah. If deadline is greater than or equal to block number, return proposal state.active. If quorum reached proposal ID and vote succeeded, return succeeded, or otherwise defeated if quorum reached proposal ID but not succeeded. Okay, yes, proposal snapshot. So we've looked at that. Proposal deadline. Yeah, like you said, it takes the it's the same as the proposal. Yeah, it's the same as the proposal snapshot, but it takes the vote end and gets the deadline at the end of the vote, as opposed to the start of the vote. Okay, proposal threshold is the number of votes required in order for a voter to become a proposer, 0. So here, anyone can propose. But you could override that and set it to something.
Yeah, look at the quorum, how it is.
Yeah. So it takes in a proposal ID and it returns a bool. Huh. The number of votes.
How is it implemented
cast.
now?
Yeah, I'm wondering. Maybe this is something that in your code, once you've inherited, you have to implement. So we might see that in the federal government as Solidity. He might override it and then implement it.
Yeah.
Same with votes succeeded, needs an implementation. Okay, get the vote weighting of a count as a specific block number for a vote described as params. So get votes takes in an account, which is an address, a block number, and bytes params stored in memory. Returns uint256, and again, it isn't instantiated. It's just like this almost looks like an interface, the last few. Okay, count vote. Yeah, same thing. It's no implementation. It takes in a proposal ID, account, support, weight, and params. Okay, so they made this generic and can represent various things depending on the voting system used. Default params just returns an empty string, and then there's a propose function. This is probably quite important. So it takes in similar things as that one we saw earlier. So it takes in an address array of targets, a uint256 array of memory values, a bytes array of call datas, and a string memory description. So the last one was taking in that hash, but this takes in the actual description, which is nice because you want to propose and actually see what you're proposing, I suppose. Require get votes message dot send. Okay, so earlier we saw proposal threshold, which said the number of votes someone needs before they can propose.
Yeah, that's proposed. Just 0.
Yeah, so we can change it, but if it was 0, then this would automatically pass.
Yeah.
Unless the block number was like 1, but it won't be. Okay, so then, yeah. Otherwise, it'll revert with governor proposer votes below proposal threshold. Then we have the proposal ID, hash proposal. So we saw that earlier. So this took the hash, but then it cast it to uint256. Require targets.length equal to values.length, yeah. And targets.length equals call data.length, yeah. So you don't want to have random leftover values or targets or call datas, and this will be equal. And then it will also all be greater than 0, otherwise it'll be an empty proposal. Cool, then we have an instance of the proposal core struct stored in storage called proposal, and it's proposal's proposal ID. Require that the start is unset. So I think what that means is like we haven't actually put a proposal yet. So require that there's no proposal, that this proposal hasn't already been started. Then snapshot, block number 2, uint64. They probably just did that to save gas, plus voting delay to uint64. We haven't seen voting delay yet, but I'm sure we'll see it soon. Then they get the deadline. So that's snapshot plus voting period, yeah. Then they set the deadline for the start, which is the snapshot, and then they set the deadline for the end, which is the actual deadline for this whole thing. Then we emit a proposal created with everything. So the proposal ID, the message sender, targets, values. Interesting, a new string array of targets.length. Why is that a string array? Because we're going to get back targets.length, which will be a uint.
Yeah.
Oh, it's saying it's a new string array of the size of targets.
These targets, yeah.
But that's going to be blank for now. So I wonder what goes in there. Then we have call data, snapshot, deadline, and description. And we return the proposal ID. So now it's successfully being created, and we return the ID. To execute, we take in the targets, values, call data, and description hash. Public payable virtual override returns unit 256, and it's probably payable because we're going to take in those vote ERC20s. I assume, but let's see. The proposal ID is the hash proposal. Yeah, so we get that hash proposal. Status. Yeah, equals state. We require status equals succeeded or status equals queued. Otherwise, it's not a successful proposal. Now we're going to execute it. So we set executed to true. And we emit proposal executed. And then we do 3 internal function calls. Should we check them out, maybe? Here it is. So this is the hook before execution is triggered. Before execution, it takes in the proposal ID, targets, values, call data, and description. It's interesting that they comment these out and they don't actually name them. If executor not equal to address this, yeah. Interesting. Okay, then there's a for loop. For I equals 0, I less than targets.length, increment I. And yeah, I've noticed lately that ++I saves more gas compared to I++, because it actually has, 2 less opcode calls. If targets I equals address this, okay, cool. So now we're trying to find the address that is actually executing in the targets. Then we do governance call pushback. Okay, so remember we had that.
The governor who is executing.
Yes, exactly. And then pushback might be to put them back on that queue, I think. I don't know.
Governance code.
Then we have after execute. Where is execute? Okay. So then we call execute. Here it is. Takes in all the same stuff. Okay, there's an error message. Governor call reverted without message. It goes through targets again. Increment is a loop. It has and then we do a call on targets with the values. So what they're taking is this is the address. So targets I will be an address, and then they perform a call. So they're saying from that address, perform a call where the value is values I with the call data's I. I haven't seen that before, but that's really nice and elegant, actually. And then this will return a success and return data. And then we take the address, dot verify, call result, success, return data, and error message. I don't know where address comes from, though. It might come from context, actually. No. Do you know where address comes from? Yeah, I don't know. And then we perform an after execute. Takes in everything again, except instead of the description, it's the description hash. If executor is now not equal to address this, and if the government's call is not empty, then clear it. So make it empty. So now it's been executed and we clear it. Cool. And then we return the proposal ID. So now we've executed it and it's been successful. David's just having some internet issues, so I'll carry on. Cool, so we've looked at execute and before execute and after execute. So all after execute does is just clear the governance call. But if you want, you can cancel a proposal. It locks up the proposal timer, preventing it from being resubmitted, marks it as cancelled to allow distinguishing it from executed proposals, and emits an event. So this takes in the same stuff, the targets, values, call datas, and description hash. We get the proposal ID again in the same way we've been doing, and we get the status, which is that state function. So it's the same as how we've been doing it. Require that status is not equal to cancelled, and it's not equal to expired, and it's not equal to executed. So it's still pending or active. And then make cancelled equal true, and then emit cancelled and return the proposal ID. Okay, yeah.
Get votes.
Yeah.
Yeah, it was not implemented, I think.
Yeah. That was the one that wasn't implemented. Yeah, you're right. I think it's because it's something we're inheriting. See, it says C I governor.get votes.
Oh, okay.
So that's why those weren't implemented. They were implemented. Well, they wouldn't have been implemented in the interface, but you can use the interface here. Maybe we can look at that later. And then get votes with parameters. Cool. That also wasn't implemented except for in the interface here. Okay, cast vote. You put in your proposal ID, so you can vote for any proposal that's active or pending. And then you put in your support, so uint 8. So I'm assuming that's like 0 is vote against and 1 is vote for, but I'm not entirely sure.
They have actually 3. You can vote against, you can vote for, and you can abstain, I think, yeah.
Oh, okay, that makes sense, yeah, good catch. And then cast vote with reason, that's nice. So you can add why you're voting that way. Cast vote with reason and params. So that could be nice, like let's say we're voting for changing the fee on a liquidity pool or something. You can cast the vote, say, yes, let's change the fee, and then put in the fee you want to change it to.
Yeah.
Okay, and then here, you were right earlier when we saw that ECDSA, we're going to sign something. So cast votes by signing. So then we have proposal ID and our support, but we have extra uint 8 of V and bytes 32 of R and S. So voter equals ECDSA dot recover, hash type data V4. So we take the ballot hash, the proposal ID, and the support, ABI encode those, and then Ketchak hash them. And then we return, and when we return, we call the cast vote function, that one that we saw without implementation. Same thing with reason and params by signing. And then, here's cast vote. Oh no, it just calls the internal one. Here's another cast vote, but it takes in different a different amount of parameters. I would call it something slightly different. I wouldn't have two at the same. I know they take in different amount of parameters, but I would call them something different. Here's relay. Relays a transaction or function call to an arbitrary target. In cases where the governor executor is some contract other than the governor itself, like when using a Timelock, this function can be invoked in a governance proposal to recover tokens or ether that was sent by the governor contract by mistake. Note that if the executor is simply the governor itself, the use of relay is redundant. Okay. And this can only be done by the governance contract. Executor we've looked at on ER 721 received. It's just override from the ERC's 721 received that we inherited. And then you can also batch receive. Okay, cool. So that's the governor contract. And that's the first thing inherited in federal government. It also takes in governor votes quorum fraction, governor Timelock control and governor compatibility Bravo. So this is both the alpha and Bravo compatible for both voting systems. Do you think we should look at this governor votes next, or do you think we should dig into the federal government?
We should dig in.
Okay, cool. Yeah. So the constructor is ERC20 votes token. So there's a token that he made that's an ERC20 for voting, and we'll see that soon. But I think governor votes, which he imports here and inherits here, is it is an ERC20. So that's why he can just say ERC20 votes token here. And same with Timelock controller. Governor Timelock control will have Timelock controller. So he takes in those two parameters, and then it sets governor. We're calling it the federal government. We pass token to to governor votes. We pass 4 to the quorum fraction. Do you know what a quorum fraction is?
Yeah, the quorum fraction is like the acceptable amount of votes from the total supply. So
I see.
So like a fraction that needs to be met in order for the vote to be valid, because not everybody will vote. So that's the fraction that's
Okay,
so this
thanks.
is 4% of the total amount. So if 4% of people vote,
then it's valid. It can be passed. Yeah. Okay, thanks. And then we create a governor Timelock control with Timelock. Okay, voting delay after a proposal is created before voting starts in number of blocks. During this delay, users can still delegate voting power to themselves or others. Cool. So you wait 2 blocks, but you could obviously choose anything. So voting period, they've set to 100 blocks. So you can vote from proposal creation to the deadline is 100 blocks, I assume.
Mm-hmm.
So here they've overridden that proposal threshold we saw, and instead of being 0, it's 1. So you must have at least 1 governance token to propose. So that makes sense. So maybe this isn't like when we saw the Open Zeppelin contract, anyone could vote. In this one, only people with a governance token can vote. So maybe this is more like, I don't know much about American politics, but it's the state, what's it called? Like the people who, like we have like ministers, the people who can cast votes in for proposals in government. I don't know what it's called in America, but so this will be like this isn't a normal citizen. This is a government official.
No.
Okay, these are just overrides required by Solidity. Good to know. So quorum, block number, and then this is super dot quorum. So this is what you were saying is that percentage, I think, or was that only the quorum fraction? Is quorum something different?
I think this one is different. This one looks different.
Okay.
Because they're using the block number.
Yeah. So maybe we should actually look at governor votes quorum fraction.
Yeah.
Go back here. Sorry. It's extensions, I think. Wow, there's a lot of stuff you could dig into. Wait, this is quorum fraction. And this one was just quorum. Oh, no, quorum fraction.
That's not just quorum, yeah.
Takes in governor votes. Okay, it uses checkpoints for history. There's 2 private variables. And then in the constructor, so this is where they're passing in that block number, and this is the quorum numerator value in UN256. And then it's calls update quorum numerator. So let's see what that is. Changes quorum numerator, emits an event. Okay, so just literally just updates it. And then, here's quorum, that function we were looking at. So it takes in a block number, And okay, so all it does is it works out the quorum, which I think like what you explained is the number of votes we need for this to be valid. But that changes by block number. So it takes in the supply times by the numerator, divide by the denominator. And the numerator was that block number we passed in the constructor. So we get token.getPass total supply, block number, times by quorum numerator, block number, divided by quorum denominator. And quorum denominator is always 100 in this case, unless you override it. So we pass in, so that's what you said, it was 4%. So we're always dividing by 100 to make it a percent. So it's 4, so this would be 4. So it's the total supply of that token times by 4, divided by 100. So it's to get the percentage. So it's the same as what you were explaining earlier, but now we're factoring in the token supply.
Yeah.
So if it's like saying it's not just a quorum faction. It's like if there were 200 people with governance tokens, then we actually need to factor in that 200 people could have voted. So 4% of that is whatever. So yeah, that's cool. Then here again, we're not actually implementing get votes. We're just calling super.get votes. But this get votes called the internal get votes, which wasn't implemented. So we should probably look at that interface later and see what's going on there. State as well. Well, we saw the state function previously in the Open Zeppelin. So it just calls super.state proposal ID. Function proposed, that's the same as the Open Zeppelin one. This is also the same. So this is just stuff that Solidity needed, I think, to actually override.
Yeah.
And supports interface. Okay, cool. So that's the contract for the federal government, but he also had the federal government Timelock version. Perhaps we should look at that next. Oh, it's just a Timelock controller. Should we look at this Timelock controller by Open Zeppelin?
Yeah, we should do it.
Because that's very cool, because then you can have multiple people, you can pass the vote. So it might be an extension, I think. Yeah, this Timelock compound and Timelock controller. Cool. So it's an extension of governor that binds the execution process to an instance of Timelock controller. This adds a delay enforced by the Timelock controller to all successful proposals. In addition to the voting duration, the governor needs the proposer and ideally the executor roles for the governor to work properly. Using this model means that the proposal will be operated by the Timelock controller and not by the governor. Thus, the assets and permissions must be attached to the Timelock controller. Any asset sent to the governor will be inaccessible. And that might be, maybe that's when you can call relay. If you accidentally send it to the governor, you can relay it to the Timelock controller. Warning, setting up the Timelock controller to have additional proposals beside the governor is very risky, as it grants them powers that they must be trusted or not to use. Only governance functions like relay are available to them through the Timelock, and approved governance proposals can be blocked by them, effectively executing a denial of service attack. This risk will be mitigated in future releases. I wonder how. Cool. So it's an abstract contract, and it's governor, Timelock, and governor. It has a private Timelock and Timelock IDs, also private, which is a mapping of uint to a bytes 32. We'll see this event later. It takes in a Timelock address, which is the Timelock controller. And it supports interface states. Okay, so this is all the same. Timelock, return addresses, Timelock. Where do we get addresses from? Is it from the governor? No. Maybe we'll see that next. Propose ETA. Okay, cool. So that's, you put in a proposal ID and it returns the ETA. Cool. So this is saying return ETA equals 1. It either equals 1 or 0, and then if it equals 1 or 0, assign that to ETA, either one of those two. So it can't be it can't be any other value. Function Q. Okay, cool. So now we can take a proposal and put it on the queue of proposals and send that to the Timelock. It takes in the same parameters we've been seeing. And yeah, it gets the proposal ID by hashing. Require state proposal equals succeeded. Delay, get the min delay. Okay, hash operation batch. So you hash the whole, all of these arrays into one thing, and then you time lock that. And then that is what the time lock IDs, so that array, that mapping at the proposal ID, you assign to that hashed operation batch. Then you schedule the batch, and then you emit a proposal queued, and then you return the ID. Execute, it calls execute batch, which I think we'll see now. Cancel is more or less the same as in governor. Executor, okay, now you just turn the address of the time lock, so the address through which the governor executes action, in this case the time lock, update time lock. Okay, so we didn't actually see this function, this execute batch. Oh, that must be in the time lock thing. Okay. Yeah, time lock controller. Where is time lock controller? Oh, it's in here. Oh no, it's in the parent directory. Yeah. Cool. It's access control. That makes sense. ERCs, so 2 NFT receivers. It has some constants. Timelock admin role. Okay, these are all the roles for the access control. Timestamps is a mapping of bytes 32 to UINTs. Makes sense. Min delay. There's an event we'll see. Okay, these are all events. Okay, so you set the role admin to what you Timelock role admin is Timelock role admin. Okay, I think that's yeah. Set more role admin is access control stuff, and then they all get, so all the people with these roles in the access control in the implementation contracts all get also Timelock admin roles assigned to them. Then we set up that role so we also give ourselves, well, this contract gives itself Timelock admin role. And then if we want to give optional admin, register proposals and proposers and cancelers. So that's from this array that we pass in. Register executors. So again, we have executors, and then we just register each of them. We assign that role. Cool. Only role or open role. And then, okay, cool. We just check that someone has that role. Then the supports interface is operation, returns bool registered. And then it just returns a bool is get timestamp ID. So remember, we pass in a bytes 32 ID, and then it returns a UN256, and if that's greater than 0, return true. Same with is operation pending, but this has the operation been done, basically, in terms of time, is that end time. Is operation ready? So if timestamp is greater than done timestamp and timestamp is less than or equal to block.timestamp, okay, cool. And is operation done? It get timestamp equals done timestamp. Get timestamp, it just returns the timestamp from the mapping. Get min delay, it just returns min delay. So that's always going to be the same because it's a constant. Hash operation we've seen, and hash operation batch we've also seen. It just takes the whole array as opposed to a single element of the array. Schedule an operation containing a single transaction, so this can happen later. and it calls an internal function called schedule, which I think we'll see soon. This is to schedule a whole batch of operations. Here, internal schedule. Okay, it has two requires, just to check that it's not already scheduled and that there's a good enough delay. And then we schedule it to block.timestamp plus delay. And you can cancel. We've seen that before. Execute, we've seen before. Execute batch is we haven't seen before, but it's the same with you do the whole array as opposed to just the and note caller must have executor role. Execute before call. Oh, that's just two requires. Interesting. It's almost like a modifier in a way.
Yeah.
After call, okay, that just sets to the done timestamp. Update delay. Oh, so we can change the delay. That's nice. But the caller must be the time lock itself. Yeah, message to sender must be addressed this. And then these are just the on receive of NFTs. Okay, cool. So we've seen all that. Cool. So this just sets up a time lock controller that then the federal government uses to implement time locks. And then he has a Congress token, which is an ERC20 votes and an ERC20 permit. It's the Congress token, mint message sender 3. And then, okay, they override the decimals to 0. And so it's like a whole number token. And then there's after token transfer, and then these are just the supers. Okay, these are just the overrides required by Solidity. And then he has a US dollar token as well, but it's not it's not like USDC where it's got an oracle and stuff. It's just a representation of the dollar. And maybe you could buy your Congress, these Congress tokens with the US dollars. I'm not too sure, but maybe that's why he has this. Yeah, and then he has some scripts. So he has utils for the scripts, a deploy and a verify, which is really cool to have in one script, and then a proposal scenario, which just creates the whole thing and runs it, basically. I don't know if you want to take a look at this, or I think we're coming up on time, actually, so maybe if someone's interested, they can look at this themselves. Awesome. Thank you so much for taking the time, David. It's been great looking at this with you, and thanks for choosing this interesting repo. I've always been meaning to look more into on-chain governance, so this has been really interesting.
Yeah, thank you.
Yeah, thanks. I hope you have a good Friday, everyone. This is another episode of Solidity Fridays, brought to you by Linum Labs.